Good day and welcome back to the third installment on derivatives as a function. In this video we will continue our discussion of a graphical perspective of the derivative. So the first example that we're going to start with is a common example where we are given the graph of a function f of x in red and we are asked to sketch the graph of the curve f prime of x. Now the general idea is as follows. We want to remember that the derivative at a is going to be the slope of the tangent line to the curve at a. And with that in mind, we can think specifically, when will the derivative be zero, i.e. the tangent line horizontal? When will the derivative be positive? When will the derivative be negative? And that should allow us to see kind of a general shape to the curve f prime of x. To begin, note that the tangent line to this curve will be horizontal when x is equal to 1 or x is equal to 2. So in terms of sketching that derivative, we know it's going to pass through the x-axis when x is equal to 1 or x is equal to 2. And note we can see this by just thinking about the tangent lines at 1 and 2, which will be horizontal. So where is f prime of x equal to 0? Precisely 1 and 2. Furthermore, we can ask, when is f prime positive? When is it going to be negative? And I'm just going to sketch a few tangent lines. If we pick any point to the left of 1, the tangent line will have a negative slope. Between 1 and 2, the tangent line will have a positive slope. And to the right of 2, it will have a negative slope. So that's telling us that the derivative f prime is greater than 0 only on the interval from 1 to 2. And the derivative is negative if you are to the left of 1 or to the right of 2. And this should be enough information for us to give a rough sketch of what the graph of f prime of x will look like. So the graph crosses the horizontal axes at 1 and 2. It's negative to the left of 1. And note additionally that the further you are away from 1, the larger and more negative the slope of that tangent line is going to be. So roughly speaking, to the left of 1, we're going to be something kind of like this. Now when we reach 1, the slope of the tangent line would be 0. And as you go from 1 to 2, you can see the tangent line, the slope is going to get more and more positive at a certain point. But then that tangent line is slowly going to round out and end up being horizontal again. So roughly speaking, you have a positive value for the derivative and you dip back down to being 0. And then the further you go to the right of 2, the more negative that derivative is going to become. And this gives a rough sketch of what that derivative function, y equals f prime of x, will look like. Now, let me note there are circumstances or scenarios where we can be much more precise than we were for this example, which required a bit of kind of guesswork and intuition on our part. So for this remaining example, what I would like you to do is to use the graph of f of x, which is a piecewise defined function made up of these 3 line segments. And I'd like you to pause the video and take a few minutes and sketch what the graph of f prime of x will look like. And remember, the value of a derivative at a point is the slope of a tangent line at that point. Okay, so now that you've taken a few minutes to sketch the graph of f prime of x, let's kind of talk our way through the procedure. Now, note there's something happening we can see at kind of -1 and 0. So let's kind of not worry about those values for now. But if I'm going to think about what's happening to the right of 0, if I pick my favorite point on the curve, and it turns out it doesn't matter which one I pick, if I draw the tangent line at that point, it's the line that precisely kind of agrees with the portion of the line segment that we are on, which is a line with slope 1/2, which gives us the value of the derivative at any point on that line, because the tangent line will have slope 1/2. So if we are to the right of 0, the value of the derivative is simply going to be 1/2. Now if we look between -1 and 0, if you pick your favorite point on the line, once again it does not matter which one you choose, and you draw the tangent line. It's going to be the line passing through that black line segment that the point lies on. And by inspection, we can see that this is a line that has slope -2. And the slope of that tangent line corresponds to the value of the derivative at that point. So anywhere between -1 and 0, the value of the derivative is -2. And if we look to the left of -1, once again, pick whatever your favorite point might be, draw the tangent line, and it's a line with slope 1. So to the left of -1, the value of the derivative is simply 1. But note there's now a question that remains, and that question is as follows. What about x equals -1 and x equals 0? What can we say about the value of the derivative there? And it turns out the function is not differentiable at x equals -1 and 0, which for now I'll just make as a note, and we'll have to see some more details in an upcoming video. So just note that this function f is not differentiable at x equals -1 and x equals 0. And I just noticed that the 1 that we had written down earlier, I believe I said -1, but I forgot to write the -1 in there. And just a bit of language, note I've introduced this word differentiable, which I have not used before. We say a function is differentiable at x equals a if f prime of a exists. And furthermore, we say a function is differentiable on an interval if you're differentiable at every point on that interval. So note, if we look at the example above, the function f we would say is differentiable on the interval from -infinity to -1, -1 to 0, and 0 to infinity, where we are specifically talking about the function f above. And that finishes up our current discussion, but it does leave us with a very interesting question. Something we'll consider in our next video is, what are the defining or distinguishing characteristics of the graph of a function or a function itself in order for it to be not differentiable at some point? As we saw in our example above at x equals -1 and x equals 0, and something you may have noticed is that both of those values, the graph contains what we might think of as a sharp point. And that will be the starting point of our next discussion. So stay tuned and take care.